All right, here we are, week 6 of SAT question, and we have another student-produced response question. Reading, we got x squared minus 34x plus c is equal to 0. In the given equation, c is a constant. The equation has no real solutions if c is greater than n. What is the least possible value of n? And let's see what you guys said about this question, shall we? So, it's another mess, as you can kind of see here. I didn't go through the effort of actually cleaning this mess up just because really what it really kind of boiled down to is that there's just so many different numerical answers that we thought it was. However, there was one clear winner here with 94 of us, which amounted to a little over 70%, saying that it was, well, it doesn't even tell us what this number is, but it is a little bit less than 289. I wonder what that is. Okay, and then as far as the difficulty, you said it was pretty hard here. So this thing is heavily skewed towards probably the most challenging question that we've had so far, apparently. All right, well, here, let's go ahead and take a look at our solution, how you're supposed to go about this, and how you're supposed to go about this. You can tackle this in a number of ways. So I'm going to take you through the Desmos crutch, of course, as we usually do. I'll show you how to do it algebraically in a couple of different ways. Okay, so first of all, a little bit of background, and that is this shape right here is not a parabola. No. This is just supposed to be maybe 1 or 2 or maybe 0 points on the x-axis. That's all this thing is. It is not a parabola until we put a y in here. And so usually what we do is we take that 0 out and you make this x squared minus 34x plus c is equal to y. And I don't know about you, I don't like that y on the right-hand side. It's giving me anxiety. So I'm going to switch this around. Y is equal to negative, nope, x squared minus 34x and then plus c. Anyway, so now this shape is a parabola. So generally speaking, you know that whenever you study quadratics, if I draw myself a little parabola shape here, I'm going to turn this thing right here into a group. Okay, so this is usually what we're looking at whenever we're solving a quadratic. And the solutions for a quadratic is the same thing as the x-intercepts. The reason why that's true is because that is where y is equal to 0, right? Which is, of course, what the original problem was. So we're usually expecting to get 2 solutions. Okay, but remember that with quadratics, it is possible also to get just a single solution. And this happens when, if you scooch this thing up a little bit, boop, and it just hits the x-axis once at its little vertex point. Okay, so that's an example with just a single solution. But what this question is asking about is that it has no real solutions. No real solutions happens when this whole entire parabola is up above the x-axis. So it doesn't touch the x-axis. It has no x-intercepts. This means it has no solutions. Now, just a little background here, and that is no real solutions whenever you get into Algebra 2. About part of the way through the year, you'll talk about that if it has no real solution, it actually still has solutions. They're just imaginary, and you still get 2 of them. Anyway, so the way that we're going to do this on Desmos is this. We're just going to type in basically this quadratic equation here and leave this c off and see what it is that I have to add to my parabola so that I can get this thing. Grab it. Yeah, there we go. So that we can get our parabola, instead of having 2 solutions or 1 solution, what do we get to add to it so that it has no solutions? Here, so let's go over here to Desmos. Boop. All right, let's type that in as y is equal to x squared, and then we want to subtract our 34. Don't worry about the plus c just yet. We'll deal with, plus 34x, whoops. Again, don't worry about the plus c. We'll deal with that in a second. So now we have a terrible picture, but that's okay. We could scale it a little bit so we can see what's going on. So we can see our parabolic shape there. We can see our 2 x-intercepts, which are basically our 2 solutions there. All right. Now, the thing is I've got to translate this thing up the coordinate plane so that basically this vertex that's down here, beep, is above the x-axis. So look at where the vertex is right now. Vertex is at 17, negative 289. And you know what? Negative 289 was answered by quite a few of you, as that's the answer that you chose. And maybe what you did is this exact thing and saw that negative 289. It's like, that's my answer. However, right now, if it's negative 289, if that's your C value, then, well, you have two real solutions here. I mean, you can see this thing pretty clearly. But actually, this negative 289 only happens if your C value is a zero, which some of us also answered. Anyway, so what I'm going to do is I'm going to add something to this equation to make it go up. And now that's all you have to do really, is that if you add a number to your function, your graph of that function is just going to translate up the coordinate plane. So I'm going to do this with a fancy little slider here. I'm going to hit plus and then a little c. Let's make it the same exact letter. Yep, there we go. And then we'll add a slider. And right now, if I move this slider, you can see that this thing is going to, it translates up if I move it positive, and it translates down if I move it negative. But it's nowhere near enough, right? So I can actually click on the C, and on the inequality here, I'm going to change it. So I'm going to put it below that 289 for right now. So 288, let's say. And then let's go up to say like 300. And then I want a step size of 1. In other words, it's going to increase by 1 each time I move my little slider. All right, and then I'll go home, move this over here. There's our parabola. And right now you can see that if C was equal to 288, I very clearly have two real solutions, the two x-intercepts. So now, if I take my little slider and I move it just one space to 289, now you only have a single solution, and it's 17 right there. So anything bigger than this 289, watch what's going to happen. It's going to just move this parabola up above the x-axis. So do I put 290 then? No, because of the way the inequality is set up for the question. So I'm actually going to put 289. Now, we're not saying that the C value is equal to 289. Look what's going on. If I go back to my little question here, it says what is the least possible value of n, not of C, but of n. So if I have C is greater than 289, my n value here is the 289, and we're saying that the C value has to be bigger than that number. And that's the thing that makes our parabola up above the x-axis. So here is our solution. All right, so I'm going to give you a follow-up video, which will take you through a couple of versions of an algebraic solution of this. But here's where we're going to end it as the Desmos version.